Solving systems of equations by graphing. System of equations consists of two or more equations with the same variables, usually x and y. The solution to the system is going to be the ordered pair that satisfies all of the equations, or where the two lines intersect. Graphs of systems of equations create either intersecting lines, parallel lines, or possibly the same line. For example, we're going to solve the system of equations by graphing. Here's our system. First thing we need to do is write each equation in slope-intercept form. After that, we're going to graph the two lines and find the point of intersection. We're going to solve the system of equations by graphing. Our two equations consist of x minus y equals 5, x plus 2y equals negative 4. In order to get x minus y equals 5 into slope-intercept form, we're going to subtract the x to the other side, which will give us negative y equals negative x plus 5. Then we're going to divide both sides by negative 1, leaving us with y equals x minus 5 as our first equation to graph. Then we're going to do the same thing to solve for our second equation by moving the x over to the other side, which gives us 2y equals negative x minus 4. We also need to get rid of the 2 by dividing everything by 2. So our equation in slope-intercept form is y equals negative 1/2 x minus 2. We are going to graph both of these equations on our graph. To graph the red equation first, which I will rewrite again, y equals x minus 5, we graph the y-intercept first, which is negative 5. 1, 2, 3, 4, negative 5 on the y-axis is our first point, and our slope is 1 over 1. Rise 1, right 1, rise 1, right 1. And we can plot these points to create our line. Draw a line to connect all those points, and there's our first line. We're now going to graph the second line, y equals negative 1/2 x minus 2. Again, our y-intercept is at negative 2, and this time our slope is negative 1/2. So we're going to go down 1, right 2, down 1, right 2, and so on. You could go up 1, left 2, up 1, left 2 to create your line. Again, connect the dots, and we have our two lines. You can see our point of intersection where the two lines meet right at that point. The coordinates of that point create our solution. So our solution is going to be at the point 2, negative 3, right where those two lines intersect. We're going to go to another example. We're going to solve these equations, putting them in slope-intercept form, and then we're going to graph the lines to see where they intersect. So we'll start with our first equation, x plus 2y equals 2. We're going to move our x over to the other side, again by subtracting it. So we're left with 2y equals negative x plus 2. Divide everything by 2. Y equals negative 1/2 x plus 1. That is the first equation we're going to graph. Then we're going to solve our second equation for y. Move your 2x over to the other side. So 4y equals negative 2x plus 8. Divide everything by 4. So y is by itself equals negative 1/2 x plus 2. When we graph our two equations, again we start with our y-intercept for our red line at positive 1. And we can see our slope is negative 1/2. So down 1, right 2. Down 1, right 2, or up 1, left 2, up 1, left 2. Connect the dots, and there is our red line. As we go to graph our green line, you can see our y-intercept is at +2, and our slope is also at -1/2. So again, we're going to go down 1, right 2, and continue in that pattern. We will graph our green line. Connect the dots, and you can see by looking at these two lines that they never intersect. They are parallel lines. Parallel lines have the same slope. And parallel lines never intersect, so it is no solution. Going on to our third graphing example, we have our two equations that we need to solve for y. Again, let's start with our first equation. If we subtract 9x, we are going to get -6y equals -9x minus 6. We do have to divide by -6 on both sides. So we get y equals 3/2 x plus 1. That's the first equation we're going to graph. Then we go to the second equation, subtract 6x, -4y equals -6x minus 4. Divide everything by -4. So y equals 3/2 x plus 1. What do you notice about the two equations? They are identical. So when we graph, we're only going to be graphing one line. Our y-intercept is at +1. Our slope is 3/2, so up 3, right 2, or down 3, left 2. And then we have our one line. Because these graphs created the same line, there are infinitely many solutions. So in summary, we came up with 3 different types of solutions. Intersecting lines create one solution. Wherever the two lines intersect, that's your solution. It happens when the lines have different slopes, and the lines are considered to be consistent and independent. Our next type of graph or solution occurred when we had the same line. Same line has infinitely many solutions. Same slope, same intercepts, it's considered consistent and dependent. And the last type of graph and solution had parallel lines. When we have parallel lines, our lines do not intersect on the graph, so there is no solution. It happens when our lines have the same slope but different intercepts, and our graph is considered to be inconsistent.